What's up everyone, it's Stack Lessons here. Welcome back to the channel. Today we're diving into data security, IAM, KMS, encryption, and VPC endpoints. Let's get into it. Picture this, your Glue job just timed out in production. Your Redshift COPY is throwing access denied, and your auditor is asking who decrypted patient data last Tuesday, and you have no answer. All three of these problems trace back to the same 4 security primitives, and by the end of this video, you'll know exactly which lever to pull for each one. We'll walk through IAM roles, KMS encryption, credential storage, and VPC endpoints. The 4 pillars that anchor the security domain on the Amazon Web Services Certified Data Engineer Associate exam. Here's why engineers get security decisions wrong in production, not just on the exam. Cheaper sounding options often look right at first glance, until a compliance review or a credential leak proves otherwise. So learn this decision rule and you'll save yourself in both worlds. When a requirement mentions audit, who decrypted what, and when the cheapest storage option cannot satisfy it. When a requirement mentions rotation, credentials that change on a schedule, the free credential store cannot satisfy it. Match the requirement word to the capability and the right answer becomes obvious. Every time Nexer Retail's Glue pipeline runs, all 4 of these pillars are in play simultaneously. So this is engineering knowledge first, exam knowledge second. First, IAM answers the question of who can do what, roles, policies, and trust relationships. Second, KMS handles encryption and, crucially, the audit trail that proves who decrypted what. Third, the credentials pillar covers secrets manager and parameter store, where you stash database passwords and config values. And fourth, VPC endpoints keep your data traffic off the public internet entirely. When a real outage or a scenario question lands on your desk, your first move is the same: identify which pillar you're inside. Before we go deeper, lock this mental model in. An IAM user is your personal badge. It has your name, your long-lived credentials, and it follows you around. An IAM role is fundamentally different. Think of it as a costume hanging in a closet. Any authorized person or any Amazon Web Services service walks up, puts on the costume for a shift, and inherits its permissions temporarily. When the shift ends, the costume goes back. Nobody owns it permanently, and the credentials expire automatically. That's why every Amazon Web Services data service uses a role, not a user. No long-lived secrets to leak. Every service role needs 2 separate policies, and they answer 2 different questions. The trust policy on the left says who is allowed to assume the role. For a Glue job, the trust policy names the Glue service principal, glue.amazonos.com. Without it, nobody, not even Glue itself, can wear the costume. On the right, the permission policy says what the role can actually do once it's assumed. It lists the API actions like S3 get object or KMS decrypt. Without permissions, the costume has no powers. The exam will show you a broken role and ask why a job is failing, and the answer is almost always one of these 2 policies. 3 execution roles dominate the data engineering exam. First, the Glue execution role reads and writes S3, talks to the Glue data catalog, writes to CloudWatch logs, and decrypts with KMS when your data is encrypted. Second, the Lambda execution role needs the Amazon Web Services Lambda basic execution role policy for logs. And here's the gotcha. If the function runs inside a VPC, attach the Amazon Web Services Lambda VPC access execution role policy too. Without it, the function can't even start. Third, the Redshift IAM role is attached to the cluster itself and referenced directly in your copy and unload SQL. The cluster uses that role to talk to S3, not the user who ran the query. The common thread: every managed service that touches your data acts on its own identity. and that identity needs least privilege permissions for every resource it reads, writes, or decrypts. Look at this copy statement carefully. Nexer Retail is loading sales data from S3 into Redshift, and notice the IAM role line. That role RN is what authenticates the read from S3, not the user who ran the query. The role must be attached to the cluster's role list in the Redshift console, and it must have S3 get object on the source bucket. If the data is encrypted with KMS, the role also needs KMS decrypt on the key. Forgetting any of those is the most common reason a copy command fails, and it's a frequent exam scenario. The fix is never to hand out user credentials, it's always to fix the cluster's role. Cross-account access shows up constantly in data engineering because real companies have separate accounts for dev, production, and different business units. There are two patterns, and you need to know both. On the left, the assume role pattern. Account A's role has a trust policy that says account B is allowed in. Account B calls STS assume role, gets back temporary credentials, and acts as the account A role. It works for any Amazon Web Services API. On the right, the resource-based policy pattern. The policy lives directly on the resource in S3 bucket, a KMS key, a secrets manager secret, and it names the cross-account principal by a RN. No role assumption needed, but it only works on services that support resource policies. The decision queue is scope. A single bucket or key means resource policy, broader access means assume role. There are 4 encryption options for S3, and the right question to ask is, who holds the key? SSE-S3, Amazon Web Services owns the key, free, 0 config, no audit trail. SSE-KMS, you own the key, every call is CloudTrail logged, but you pay per API call. SSE-C, you send the key on every request. Amazon Web Services uses it then forgets it, and lose the key and your data is gone. Client-side encryption, you encrypt before upload. Amazon Web Services never sees plain text, and you own all the complexity. The decision usually comes down to whether you need an audit trail. If so, SSE-KMS is the answer. If you only remember one analogy from this entire video, make it this one. SSE-S3 is a hotel room safe. It's convenient, it's free with the room, and your stuff is locked up, but nobody is keeping a record of who opened it. SSE-KMS is a bank safety deposit box. The bank logs every single visit, you can revoke access by changing the key policy, and there's a paper trail an auditor can pull on demand. When the exam mentions compliance, auditing, or proving who accessed encrypted data, your answer is KMS. When it just says simple or default, S3 managed keys are fine. One nuance the hotel safe analogy doesn't capture is hiding in this sentence. The phrase including Amazon Web Services using KMS on your behalf. When a Glue job decrypts an object, when a Redshift cluster reads an encrypted file, when a Lambda function unwraps a secret, every one of those operations is logged under the role that Amazon Web Services used to call KMS for you. So you don't just see human access, you see every managed service touching your encrypted data with the identity that authorized it. That's what makes the trail genuinely independent and trustworthy in an audit. Here's your decision rule, side by side. Pick SSE-S3 when the question emphasizes simplest or cheapest, when there's no audit requirement mentioned, when the data is internal with no compliance angle, or when the question literally describes default behavior. Pick SSE-KMS when the audit trail matters, anything about proving who decrypted what. Also pick it when you see compliance terms like HIPAA, PCI, or SOC. Cross-account encrypted access needs KMS because you need a key policy to grant the other account decrypt permission. And anything about key rotation or revoking access also lands on KMS. The trap answer is always the cheaper one when the requirement actually demands audit. Now to the credentials pillar. Secrets Manager on the left auto-rotates secrets using a Lambda function that Amazon Web Services provides for you. It has native integration with RDS, Redshift, and DocumentDB. It supports cross-account sharing through a resource-based policy, and it costs about 40 cents per secret per month. Pick it whenever credentials must rotate on a schedule. Parameter Store on the right is essentially free in the standard tier. It's a hierarchical key-value store, and the secure string type is KMS encrypted. But here's the critical point: it has no native rotation. Pick it for static configuration values like database hostnames or feature flags that don't need to change. The decision is simple. Does it rotate? Secrets Manager. Is it static config? Parameter Store. Worth understanding how rotation actually works under the hood, because this is what you're really buying when you choose Secrets Manager. On the schedule you set, Secrets Manager invokes a Lambda rotation function. That function creates a new version of the secret, configures the database with the new credential, tests that the new credential works, and only then marks the new version as current. 4 stages: create, set, test, finish. If the test step fails, the old credential stays active and you get an alert, so a broken rotation never takes down your application. Parameter Store has no equivalent handshake. You'd have to write all 4 stages yourself, and you'd have to handle the rollback logic too. Now to the network pillar. VPC endpoints exist for one reason: to keep your traffic on the Amazon Web Services backbone instead of routing through the public internet. There are 2 flavors, and they're not interchangeable. A gateway endpoint is just an entry in your route table, free, and it works only for S3 and DynamoDB. Those are the only 2 services that get a gateway endpoint. An interface endpoint is a real elastic network interface, an ENI, with a private IP address inside your subnet. It covers KMS, Secrets Manager, and almost everything else, but costs about $7 per month per availability zone, plus data processing. Free versus paid, 2 services versus everything else. Let's turn this into a discrimination drill, because the wrong answers all look plausible. If a scenario says the team set up a gateway endpoint for KMS, that's wrong. Gateway endpoints work only for S3 and DynamoDB, period. If a scenario calculates the monthly cost of a gateway endpoint, that's wrong. There is no charge. If a scenario says the gateway endpoint was attached to the VPC and traffic still failed, that's the route table tell. Gateway endpoints are configured in the route table, not on the VPC itself. So if the route is missing, the traffic still leaves through the internet gateway. 3 wrong answer shapes, each pointing back to one of the 3 facts in this quote. Now here's the single most tested troubleshooting scenario in this entire domain. The setup: a Glue job is running in a private subnet with no NAT gateway and no route to the public internet. The symptom: the job hangs or times out trying to read from S3. The root cause: there's no S3 gateway endpoint in that subnet's route table, so the Glue job has no path to S3 at all. The fix is to create a gateway endpoint for S3 and add it to the route table, free and instant. And this exact scenario appears on the exam almost word for word, so recognize it on site. Train your eye for the phrase Glue in a private subnet, and the answer falls out immediately. Look at how the cost scales. A gateway endpoint for S3 is $0 a month. One interface endpoint in one availability zone runs about $7. But here's where it gets ugly. 5 services across 3 availability zones blows past $100 a month before you transfer a single byte. And for reference, a NAT gateway runs around $32 a month, which is cheaper than that interface endpoint sprawl. Candidates often choose interface endpoints assuming they're cheap. They're not. The exam sometimes asks for the most cost-effective private connectivity. Read the requirement carefully if it's only S3 gateway endpoint wins on cost every time. Here's a powerful pattern that ties IAM, S3, and VPC endpoints together. This is a bucket policy for Nexer Retail's secure data bucket. It denies all S3 actions from any principal unless the request comes through a specific VPC endpoint ID. Notice the resource field lists two ORNs, the bucket itself and the objects underneath it. You need both because bucket-level actions like list bucket apply to the bucket ARN, while object actions like get object apply to the object's ARN. Miss one and the lock has a gap. With both in place, even stolen credentials can't read the data from outside the VPC. The AUS:/source VPC e-condition key is what makes it work. This is the cross-account trap that catches even experienced engineers. When account A needs to read an SSE-KMS encrypted bucket in account B, three policies must all align. First, the bucket policy in account B must grant S3 get object to the account A role. Second, the IAM role in account A must have S3 get object permission. And third, the one everyone forgets, the KMS key policy in account B must grant KMS decrypt to the account A role. Miss that third piece, and the request fails with a cryptic access denied error that doesn't mention KMS at all. On the exam, if a cross-account scenario involves encryption, scan the answer for the KMS key policy. That's almost always the missing piece. Zooming out, CloudTrail is the thread that ties this entire domain together. Every IAM action flows into CloudTrail. Every KMS encrypt and decrypt call flows into CloudTrail. And VPC endpoint usage shows up there too, because the source VPC endpoint ID is recorded in the event. CloudTrail consolidates all of it into a single unified event log. That log lands in an S3 trail, your long-term retention archive for compliance. CloudWatch receives the same stream for real-time alerting and dashboards. So when a compliance team asks who decrypted patient data last Tuesday from which network path, you have a single answer because three pillars all feed one log. Here's your keyword decoder. Audit who decrypted means SSE-KMS plus CloudTrail. Auto-rotate credentials means secrets manager. Cheapest static config means parameter store standard. Never traverse the public internet means VPC endpoints. Glue can't reach S3 from a private subnet means S3 gateway endpoint plus root table. And cross-account encrypted bucket means all three bucket policy, IAM role, and KMS key policy. Train yourself to spot these phrases first, and the right answer almost always follows directly. 6 things to memorize cold. 1. Service roles need both a trust policy and a permission policy. 2. SSE-S3 is simplest, SSE-KMS is auditable, CloudTrail is the differentiator. 3. Secrets manager rotates, parameter store is cheap. 4. Gateway endpoints free, S3 and DynamoDB only, root table based. 5. Interface endpoints paid per ZENI based. 6. Cross-account SSE-KMS needs 3 policies aligned, the bucket policy, the IAM role permission, and the KMS key policy. Now let's see how well you absorbed all of this with a quick 5-question quiz. All right, question 1. A healthcare company stores patient records in S3 and must prove to auditors exactly who decrypted each object. Which encryption configuration meets this requirement? Is it A, SSE-KMS using a customer-managed key with CloudTrail enabled? B, SSE-S3 with CloudTrail data events enabled on the bucket? C, client-side encryption with keys stored in parameter store? Or D, SSE-C with rotating customer-provided keys? Take a moment to think about it. The answer is A. Only SSE-KMS produces per decryption CloudTrail events, because every encrypt and decrypt call hits the KMS service and gets logged. SSE-S3 never calls KMS at all, so even with data events enabled, you'd only see the GET object call, not the decryption itself. Question 2. A Glue job running in a private subnet of a VPC times out when trying to read from an S3 bucket. There is no NAT gateway. What is the most cost-effective fix? Is it A. Add a NAT gateway to the VPC for $32 per month? B. Create an interface endpoint for S3 using private link? C. Create an S3 gateway endpoint and add it to the subnet's root table? Or D. Move the Glue job out of the VPC and use public S3 endpoints? Take a moment. The answer is C. S3 gateway endpoints are free and designed exactly for this scenario. The endpoint must be referenced in the root table of the subnet where the Glue job runs. Just creating it on the VPC isn't enough. NAT gateway also works but costs around $32 a month, so it's not the most cost-effective choice. Question 3. A team needs to rotate their RDS database credentials every 30 days with 0 downtime and 0 code changes. Which AWS service should they use? Is it A. AWS Secrets Manager with rotation enabled? B. Systems Manager Parameter Store Secure String? C. AWS KMS with annual key rotation? Or D. S3 bucket with versioning and a Lambda trigger? Think it through. The answer is A. Secrets Manager is the only service that natively rotates database credentials on a schedule. AWS provides pre-built rotation lambdas for RDS, Redshift, and DocumentDB, so there's 0 code to write. Parameter Store can store secrets, but it has no native rotation. You'd have to build that yourself. Question 4. Account A's Redshift cluster needs to copy data from an SSE-KMS encrypted S3 bucket in account B. The S3 bucket policy and the cluster's IAM role are configured, but copy still fails with access denied. What is missing? Is it A. The Redshift cluster needs an interface endpoint for S3? B. Account A must enable cross-region replication on the bucket? C. The KMS key policy in account B must grant KMS decrypt to the account a role? Or D. The copy command needs to specify the SSE-KMS key in the SQL? Take a moment. The answer is C. Cross-account access to SSE-KMS encrypted data requires 3 policies aligned: the bucket policy, the IAM role permissions, and the KMS key policy. Forgetting the KMS piece is the most common trap. Without KMS decrypt granted to the cross-account principal in the key policy, the copy silently fails with a misleading error. Question 5. A company requires that all objects written to an S3 bucket are automatically encrypted with a customer-managed KMS key with no reliance on client setting headers. What should they configure? Is it A. Enable SSE-S3 as the bucket default encryption? B. Require clients to perform client-side encryption before upload? C. Enable SSE-KMS as the bucket default encryption with a customer-managed key? Or D. Attach an IAM policy that denies unencrypted put object requests? Take a moment to think about it. The answer is C. Setting SSE-KMS with a customer-managed key as the bucket's default encryption guarantees every object is encrypted with that key, even when clients omit encryption headers. SSE-S3 uses AWS-managed keys, not customer-managed. Client-side encryption shifts the burden to clients, and a deny policy blocks unencrypted uploads, but it doesn't actually perform the encryption itself. Let's close where we started. Glue timing out from a private subnet. The fix is an S3 gateway endpoint plus the root table entry. Redshift COPY throwing access denied on encrypted data. The fix is the third policy people forget, the KMS key policy, alongside the bucket policy and the IAM role. Auditor asking who decrypted patient data. The answer is SSE-KMS plus CloudTrail. Next up, monitoring, observability, and operational excellence. The patterns that keep Nexer Retail's pipelines healthy in production. See you in the next one. Let's close where we started. Glue timing out from a private subnet. The fix is an S3 gateway endpoint plus the root table entry. Redshift COPY throwing access denied on encrypted data. The fix is the third policy people forget, the KMS key policy, alongside the bucket policy and the IAM role. Auditor asking who decrypted patient data. The answer is SSE-KMS plus CloudTrail. Next up, monitoring, observability, and operational excellence. The patterns that keep Nexer Retail's pipelines healthy in production. See you in the next one.